Is this the worst code I've ever seen? Let's find out. Dear Cherno, a couple years ago I made a, well, bad ray tracer. As I was digging through old projects and found this and thought this would be fun for you to dissect and pull your hair out. I think I'd like to keep my hair, thank you very much, while looking through it. It's very small and it's not a lot of code, but I thought I might send it over anyways. Here's the GitHub link. Let's take a look at this. Link will be in the description below. So first of all, Alex is cool 321. Like, I'm just not really sure what kind of username that is. This is a horribly made ray tracer, made in C++ and Windows.h, made in Windows.h. I love that. This only works on Windows. Who would have guessed? Uses the console and runs on the CPU. 3 features of a not very good ray tracer. 2 days ago, this is nice and fresh. Was that when he sent this? Yeah, 2 days ago, look at that. All right, so just by looking through the repository, I mean, the commit is called "this is bad," so this is going well. I love how this is just so confidently bad. Like, I haven't looked at the code yet. We'll take a look at it in a minute here, but the confidence is just astounding. I have a feeling this is not gonna be that bad. Okay, so we've got Visual Studio files in here, right? So that's already not ideal. You're gonna be using like a build system like CMake or Premake. Obviously, this is Windows only and, you know, uses Windows.h, so it's already not ideal and it's already locked to Windows. So in that case, like, you know, I guess Visual Studio project files are fine. You definitely should not have this user one though, because the user is, you know, it's for the user. It's not something you usually commit. So I would have these two, the VCX proj and the dot filters as well. All right, without further ado, let's grab this code and have a look. Okay, so here we have it checked out on disk. Let's launch this in Visual Studio. All right, we've got 2 files here that I can see, main.cpp and badRaytracer.h, which checks out. They're the only 2 files of the project. And look at this. This looks pretty clean. I wrote this like 2 years ago and I haven't touched it since. I also was way too lazy to look up a tutorial or something and just Google and figured it out by myself. All right, a bit of a flex there, unnecessary, but okay. I too like to flex about how cool I am in my code comments. Would you also like to flex about how good you are at programming? Well, then you should check out Brilliant.org, the sponsor of this video, because they have a 30-day free trial on right now that you can use to check out their entire platform. For those of you who don't know, Brilliant.org is an amazing website filled with lots and lots of really high quality courses on various STEM topics. And I think it's the perfect place for you to start your programming journey because their beginner computer science courses are really, really fun, engaging, and interactive. And they don't just teach you a specific language. They teach you how to think like a programmer, which I personally think is much more important than learning the syntax of something like C and not really understanding what it is to actually write code. And as I said, interactive. You're not just gonna be watching videos, you'll be like dragging these things around to actually control the flow of a program and learn how things work. Learning practically is so much better than just taking in theory and doing nothing with it. And then you can progress to an actual programming language like Python with, again, the same way of teaching. They've also got some AI courses, which I think are really cool. And of course, it doesn't just stop there. They've got so many other topics like data science and math. Who could forget about math? And again, taught beautifully, visually, with widgets you can use to interact with what's going on. But don't take my word for it. As I mentioned, Brilliant have a 30-day free trial that you can use to check out all the courses on their platform. Just go to brilliant.org/thecherno, link will be in the description below. And if you do go on to like it, that link will also get you 20% off an annual premium subscription. Huge thank you to brilliant.org, as always, for sponsoring this video. So this main function, this looks great. I mean, look, this is sus. Like, just looking at this, you know, if I had to like mention one thing that just kind of sticks out to me as being odd, it's running, while running. Well, where's running? It's not here, is it? The running variable is not here, and yet I'm using it. That is sus. If we just hit F12 in Visual Studio to go to where it is, we get taken to badRaytracer.h, which is the header file, which contains a whole bunch of code in it, including, well, these things here, which are global variables. They almost look like they're not because they're in a scope, and they are in the namespace badRaytracer, but they are not actually in a scope, and they are globally accessible, as you can see here. I mean, this specific thing is a little bit interesting because already failed because you're using Windows.h. That's funny. This situation is a bit simple because this program is so simple, it's 2 lines of code. Really, you could think of this header file as not really like an API per se, but more of like just a way to organize your files, right? So what we can do in C++, obviously, is we can just make a header file or make any kind of file. It actually doesn't have to be a .h file. It could be a .lol file that you can then include over here. So what happens with header files is the preprocessor will basically grab that file and just paste it in like that. If you want to learn more about how header files work, I made a whole video about that really long time ago. I'll have it linked up there. And so this, if we just get rid of like pragma once and stuff that's irrelevant, this is kind of the whole program as we're looking at it. And so obviously now it makes a little bit more sense. It's like, okay, so inside bad ray tracer, which by the way, we're using this namespace inside the main function, inside that main.cpp file. These are kind of like just variables at the top of this file, even though they are global and we're just using them. So sometimes like when you see weird stuff going on, like while running, it might seem a little weird on paper, but you have to remember that C++ is a language that is weird. We've got a clear start function. We've got a clear loop, like the actual application loop or whatever. And then we've got a clear end function, which I don't think this even gets called. Hilarious, but it's there. Like this is the structure of a good program. The only criticism I have just by looking at this is just the running situation, because that doesn't make sense. Had this been something like, you know, is program running, like that would have been much more acceptable, or like even just is running. That would have been much more acceptable. It's a function. Functions have a lot more rules associated with them than just simply having global variables. But overall, really nice, clean design. And I also like the fact that this doesn't unnecessarily use classes. That's also, I think, the sign of someone who, well, is either coming from C, which is common. What does this person say? Anything about like who they are or their programming experience? Not really. But a lot of the times universities or like school, I guess, in general, will teach C first and then might introduce C++ or Java or C#, like an object-oriented language, or a language that can be object-oriented in the case of C++. And so what you see a lot of the time is people who are going from a language like C obviously don't have any kind of mindset with like, oh yeah, I have to use classes for everything. They just bring over that C style of programming into C++, which I honestly think in the long run is actually a really good way to go, because one thing that I see very often with C++ programmers that I don't like is that they were taught C++ in a very object-oriented way. And so that's all they think exists. That's just the way that they have to write code. Everything has to be a class, everything has to be an object. Whereas I think that the proper way to write C++ is the proper way to kind of do anything in life, which is to use the appropriate tool for the job. And because C++ offers you so many different tools, so many different programming paradigms that you can use, you can kind of pick what makes the most sense in a particular situation rather than being locked into something like classes like you would in Java. So let's have a look at the start function. I don't really need it, but like, okay, so this was just bait. And actually the end function, okay, the end function actually does, so this they didn't think got called, but they were really happy with the start function, which actually does nothing. Again, that's all right. I think that if they did have initialization code, they could have put it into here, but end actually does meaningful things like, you know, cn.ignore and releases the device context. Okay, so let's just start over here. So first of all, this stuff is not in a function for some reason. That's a little bit odd. It's just kind of floating in global memory, and then we're just kind of calling these getters, I guess, in like a global like thing. I wonder if we put a breakpoint here. Oh, actually, I haven't run this. Let's run this. I completely forgot to run this. Okay, so it builds all right, and there we go. There's the result. It's just this green thing, which I could have drawn myself. Actually, let's see how good of a job I can do with zoom it. Okay, pretty bad job. But anyway, we've got this like sphere, I presume, that's just sitting in the middle, and you can see if I rerun this, you can see how it kind of renders it. It kind of goes line by line inside the console, right? We're actually in the console window itself. Oh, it's doing it again. I wonder how it decides that. But anyway, and it's just rendering this like sphere, I guess, that's in the middle. So we'll have a look at the math and the code that makes that happen in a minute as well. But anyway, if I put a breakpoint here and I run this, if you have a look at what's going on, because we are obviously calling this code, it's working, but if you have a look at what's going on, you're actually calling that code from this main CRT C runtime is what CRT is. You're kind of calling it from the main like CRT startup, which is actually before the main function. If we double click on this over here to just look at this main like function or whatever situation, this exists in like the C runtime, and at the moment we're like somewhere up here, but eventually we're gonna go down here and you can see we're gonna invoke the main function. This is the function that will call our main function that we've written, and you can see it grabs the result and then it can exit like with that code or whatever. So this is like pretty cool because it's the code that runs the code. And we thought that maybe the code was all that existed, our code, the main function. No, this code calls the main function. Something always calls something else. I am generally a big fan of not ever doing this, meaning like not ever calling code outside of like I just don't think that we should be calling code outside of the main function. Anything that's kind of user-based, unless there's a very good reason for it, but otherwise in this case, like I wouldn't be trying to do this in like this main startup function or whatever before our main function. I mean, we want to in general maybe not initialize global variables just like this in global space before our main function, but the reason why is because we just don't really have that much control over what actually happens over here, and there's also a huge limit as to what we can actually write. Like if we wanted to validate whether or not this successfully like managed to get us a console window or the device context, we can't because this is not a block in which we can just arbitrarily write code. It's a place to declare variables, and like setting memory, you know, like something like this I think is okay, but when you start calling functions, especially kind of serious functions, I think that that's exactly what that start function that does nothing is for. So we call the start function. Why not just have this stuff in there? So you can paste this in, get rid of these types, right? So we have these over here, and then this can simply just be like null or 0, or I think there's like a special thing you can use, but you could just set it to like null pointer or something like that up here, and then create it in your start function. Because first of all, that means that like the startup, the initialization of your program actually happens at a particular, very well-defined point in your program, but then you can also like assert or like verify or log that, like, you know, whatever it might be that you might want to do around this code, you can actually do because you're in a real function now and not just in like some global like variable space. So once we have access to the console and everything, the next major thing we do is, well, running, I guess, gets set to true immediately. So that's taken care of. It just gets initialized as true. By the way, that's another thing you might want to do. You might want to basically set running to true inside start conditionally based on whether or not the initialization actually succeeded. So if something went wrong during the initialization, you could leave running on false, and that way you're not going to try and run this loop and possibly crash with some memory access violation because you can't actually write anything to the console. Instead, you just jump straight to end, and then you can obviously like just close down the program or just tell the user that, hey, nothing worked. So that's probably something I would also do. Set running to like true specifically in start, and then obviously set it to false conditionally if that didn't work out. Okay, so now we're in the loop. This is the thing that runs every single frame. And I don't exactly know what a frame is because we're not like, we'll see potentially, but it's just like every iteration we run this. Okay, so this, I mean, looks like just looking at this code, it looks great. Like, it looks fine. This is just, I think I just got baited. I think this code is completely not horrible or terrible or the worst code I've ever seen ever at all. I mean, the only thing I can really think of is like y equals y plus 1 is wild. You know, I sometimes see y plus equals 1, you know, but generally we would write y plus plus if we're trying to just increment this variable by 1. So I would probably switch to something like this. Screen X and screen Y are just 250 by 250, so that's what we're iterating through. You've even got the Y as the outer loop, which presumably is good, just because generally we render scan lines like that, and that happens to be the actual memory layout, the actual memory order, and we always want to iterate through memory in order, right? So if this is just like a single dimensional array that's that long, we want to go through it like this. If we had these loops flipped around, then we would basically be going through every Y coordinate down like that, which would translate to jumping around the buffer like that. We want to go all along the buffer in a row, because when we try and access memory, we'll prefetch a bunch of it, it'll remain in the CPU cache, and accessing it's gonna be much faster than jumping around the buffer, potentially. So for this to be the worst code I've ever seen, I mean, we'd have to flip this and do it like this. By the way, this is all presuming the memory layout is normal and sane. I haven't actually looked at it, obviously. We don't know what X and Y are actually accessing, but they are setting pixels at X and Y, so presumably the console buffer will obviously be laid out like I said, in which case, yes, having the horizontal scan line as the inner loop is superior. Okay, so what's this ray class? Or like struct, it's the class. Okay, so this is a good example of, you could probably make this a struct because you just got public and then you've got nothing private here, so it might as well be a struct. I love Google, nice. So we've got a whole bunch of floats here, origin X, Y, and Z, and direction X, Y, and Z. And then we've got some math that just looks absolutely horrible to read. I think since you're on the topic of making, you know, if I really had to tell you how to improve this code, or at least my opinion, I'd probably have like a vector 3, just like this, that you could then have be like the origin and the direction, just because it first of all helps to describe the code a little bit more, because someone looking at this might be like OX, OY, OZ, DX, DY, DZ, what on earth does that mean? Obviously people who are somewhat experienced even a little bit with like ray tracing and you know, a class called ray could guess pretty easily what that is, but this is even better. I guess the only potential downside is it would physically increase like the size of this math, right? So float A would look instead, let's just call it A2, would look instead something like, you know, direction.x squared, and then direction y squared, direction z squared. So it obviously has expanded from being this long to this long, but you know, I think that it's fine, honestly, in my opinion, for code to be long as it's like meaningfully long. And if you're using variable names that just describe what's going on and make it easier to read and add clarity, I think that longer code is actually better. But I also understand that if specifically with math, you want to keep variable names short, which is something that people tend to do in math, which is totally fine, then at least having like some kind of comment that explains this might help. Okay, so all of this is just using the quadratic formula to solve an equation. We basically have a circle defined, and then we have a ray going from the origin across the direction, going through it, and we're trying to find if it has 0 solutions, meaning 0 intersections because it misses, if it's got 1 because it's like right on the tangent, or if it's got 2, which is common. And these 2 points over here in orange basically correspond to T0 and T1, where I'm assuming the smaller one is probably the one closer to the camera if the camera is like over here. And then this one, since we're adding the square root of the discriminant, will be the one further away. This discriminant here in the middle just lets us figure out if there are no solutions, meaning we've missed completely, so that we can early out. Again, the presence of this in general is obviously good. It means that you potentially understand what's going on, or you copy this from somewhere. But the point is, it lets us avoid doing this, which wouldn't exactly work in the first place because we'd be trying to square root a negative number. But anyway, it lets us avoid doing more code by earlying out if there are no solutions. So this is good. And for those of you who have no idea what's going on, quadratic formula, Wikipedia, x equals minus b plus minus this, which is the discriminant, the part that is inside this square root divided by 2a, you can see that's exactly the code that's happening here. There's square root of the discriminant, which is this part, divided by 2a. You probably should have learned this in high school math. And yes, it is useful in real life, turns out, even for something as exciting as ray tracing. Yeah, look, I can't fault this. Like, I think this is totally legit. I mean, you could take this a little bit further by calculating like actual positions and normals just from these points, because you've got the points of intersection. If you know where the sphere is in 3D space, then figuring out the normal is simply drawing a vector to the intersection point, and that is your normal. Once you normalize it, you've also got the actual points of intersection. So basically from this simple quadratic formula to solve the equation, you figured out a point of intersection and which way that face is effectively facing. And that could be used for something like adding some lighting to this model. Okay, going down here a little bit. So if we do have an intersection, then we set the pixel to be green. Otherwise, we set the pixel to be black. And that's obviously what we're seeing in the final rendered result. And then we do frame plus equals 1. So you got plus equals here. I don't know why you had like x equals x plus 1 or whatever there, which again, I would generally write frame plus plus. Frame's not really used for anything, but I guess you could use it for animation. Let's declare it up here. And that's basically the whole program. We just draw like a green dot, a green pixel if we did have an intersection, and we draw a black one if we didn't. Really, really simple stuff. Again, can't really fault this code too much. Let's maybe think about what I would do if I would be the one writing this code. I'd probably put all of this, I did mention, having this be at least not initialized here, but I wouldn't have this in the first place, right? I'd probably make like a class called application, and that would, like, as member variables, contain all of this stuff. I would try and organize my math a little bit more using vector 3s, like I mentioned. I think also introducing a CPP file might be worth doing. Like, it's not, usually we have CPP files to avoid recompiling everything, because if we just have our code in header files, like you see over here, what that means is that every single time we change something, it has to then recompile every single CPP file that includes that, because as I mentioned earlier, it just copies and pastes this code into a CPP file. So obviously that CPP file that includes this has also then changed if this changes. To avoid that, we could define this function inside a CPP file. So we would just have it declared like this, and then we would make a CPP file. I'm just gonna go to main.cpp, but you can make a different CPP file called like badRaytracer.cpp, I guess, and then you can paste that in. So let me just grab the declaration over here, and we'll make sure that it's inside the ray class. And now you can see that if I change any code here, it's kind of inside a CPP file, so only this CPP file will be recompiled. Now in this specific project, we have one CPP file and we've got one H file. So this is gonna make zero difference, but it's just a good habit, I think, to get into. It also makes looking through your like class declarations and your code declarations a lot clearer, right? Because I don't have to scroll through a lot of math and code. Like for a function I might not be interested in, I just get an overview of what's actually present, which is good. Again, start, loop, and end I would put into like an application class. I guess I could quickly show you what I mean because this was kind of short. So we have application. This is also a situation where I would not be opposed to doing initialization code in the constructor because it is so brief. You could obviously make some kind of init function or a start function and end function like you did, but I think that's not required here. It's funny how I was talking about how it's nice that this wasn't object oriented and now I'm kind of making this a class. A little bit ironic, but I think in this case it actually fits pretty well. So let's actually go ahead and make a bad ray tracer CPP file. Never did I ever think I'd be making a CPP file called that. We'll grab this namespace as well, pop it into the CPP file. Okay, so what do we need? Application, constructor, and destructor, and then probably just loop. Loop would actually contain the loop in my example. So I think maybe I just have a function called run, which would run it. And then as private members, I would have all of this. I'd probably also call them, you know, m underscore whatever, my naming convention, but we'll ignore that for today. Let's get rid of this. Okay, and then we have like start, loop, and end. So let's just grab these three functions. We'll put them into the CPP file that I just made. But the difference is we're gonna have this stuff, the stuff that was in the start function inside the application constructor. I guess I'll rewrite this in my style as well. The destructor is going to do the stuff that we had inside end. So that stuff's now in here. And then loop is what we called run. Screen X, screen Y, you could probably bring out into a renderer class if you wanted to. Again, that makes sense if you're going to extend this and make it a lot more complicated, because that way you can separate your concerns. Like application stuff can be related to just general application initialization and running the loop and stuff like that. Whereas rendering is gonna be inside the renderer, that makes sense. But I'll leave it obviously in here for now because this is pretty easy. And this is also where I actually want to have that while running loop, right? So we can have while running over here. And then since we are literally rendering, I think it would be probably nice for us to potentially make a private function here, which I can add under a separate section, just so that it's a little bit more clear that it's just not a variable, it's a function. And if we create an implementation for that, that can actually do this section over here. So frame++ I might keep inside application running because that makes sense for us to maintain a frame index in the application loop itself. But then this could just simply call something like render and then increment the frame. And then the render function is the one that's actually doing the rendering, which obviously makes sense as well. That's pretty much it. Just clean up these silly comments. Another cool thing I think about this is that if you really wanted to, it could mean that windows.h could actually go into just the CPP file, so you're not having it in the header file that's included everywhere. Potentially useful if you want to, like, I don't know, make different implementations of this for different platforms. We're not going there with this, obviously. And also, you know, these two things you'd have to either just use void pointers for, or like, you know, have some kind of type declaration maybe included. I think there's like a header, I forgot what it is, that just has the Windows types definitions that you can actually also technically include on Linux and Mac and any other platform, because it's just a bunch of types. It's not no actual code or implementation, but it would mean that you could still declare variables like this in header files if you wanted to. But again, we're not going to talk about how to set this up for multiple platforms here today. That's beyond the scope of this. And then we've got our vector3 if we need it. We've got our array if we need it. We're not actually using this, obviously. And then the implementation of sphere intersection. Why not? We might as well move into bad raytracer.cpp. I'll just put it at the bottom over here so that it's not inside our main function, or rather our main file. Okay, so yeah, and obviously I would split this up potentially into like array.ash, array.cpp if you wanted to. Again, I don't think it's a big deal for a project of this size, but it's definitely something that you could do. And then inside the main function, we obviously need to clean this up. So, I mean, this would be really simple. We just have application app and then app.run, and that is the entire program that we would have here, right? And return, by the way, 0 is optional for the main function because the C++ standard allows us to not return anything specifically for the main function, and it will just return 0 by default. So if you want to keep it even cleaner, you could do something like that. And I probably wouldn't necessarily use namespace bad ray tracer for just one line of code. I'd probably write something like this. And that's it. I guess we should see if this works. And there we go. Same exact result as before. Our little rendering console situation that changes every time we do this, which is kind of cool. I mean, it's running in a loop, which is why it never really stops. And then I don't know if we have a way to actually stop it. Yeah, we don't. But if somehow you set running to false, then it would just progress past this into here, and then reaching the end of the scope here for this object that was created on the stack, it will call the destructor, and that will clean up and do everything that it needs to do to shut down the application. And that's it. So look, honestly, this is very, very far from the worst code that I've ever seen. If anyone has any actually bad code that they want to send me and then maybe see me improve, or at least improve in my style, subject to my opinion, of course, then please send it into chernoreview@gmail.com. That email address and instructions will be in the description below. What did you guys think of this code? like not the worst code ever, right? Like very, very far, I think, from the worst code ever. It worked well. There weren't even any memory leaks. Everything went like, even like the CPU cache was basically taken into consideration. Probably not like consciously taken into consideration, but there wasn't anything like egregious or just horrifying at all going on with this code. So well done, you tricked me. Still waiting for some actually bad code. I'll see you guys next time. Goodbye.